Hello and welcome to the Machine Learning Podcast, the podcast about going from idea to delivery with machine learning. Building good ML models is hard, but testing them properly is even harder. At DeepChecks, they built an open-source testing framework that follows best practices, ensuring that your models behave as expected. Get started quickly using their built-in library of checks for testing and validating your model's behavior and performance, and extend it to meet your specific needs as your model evolves. Accelerate your machine learning projects by building trust in your models and automating the testing that you used to do manually. Go to themachinelearningpodcast.com/deepchecks today to learn more and get started. Data powers machine learning, but poor data quality is the largest impediment to effective ML today. Galileo is a collaborative data bench for data scientists building natural language processing models to programmatically inspect, fix, and track their data across the ML workflow, from pre-training to post-training and post-production. No more Excel sheets or ad hoc Python scripts. Get meaningful gains in your model performance fast, dramatically reduce data labeling and procurement costs while seeing 10x faster ML iterations. Galileo is offering listeners of the Machine Learning Podcast a free 30-day trial and a 30% discount on the product thereafter. This offer is available until August 31st, so go to themachinelearningpodcast.com/Galileo and request a demo today. Your host is Tobias Macy, and today I'm interviewing Alex Ratner about Snorkel AI, a platform for data-centric machine learning workflows powered by programmatic data labeling techniques. So, Alex, can you start by introducing yourself?
Thanks so much for having me on the new show. And like you said, I'm Alex. I'm one of the co-founders and CEO at Snorkel AI. We build what we call a programmatic data-centric development platform for machine learning and AI. And I'm also assistant professor at University of Washington in the computer science department. And before that, we started the Snorkel project back at the Stanford AI Lab, where we spun out of. So I'm very excited to talk about what we do and ties into some of the broader shifts and themes we're seeing in the ML space today.
And do you remember how you first got started working in the area of machine learning?
Yeah, well, you got to cut me off if I ramble on too long about this, but let's see. I've coded since I was little, but I kind of did a detour into physics during undergrad. So then, I was actually not a computer science major. I was working actually in some consulting. I remember we were looking at the patent corpus, and I started to think it was really fascinating that you had all this information about, basically everything anyone thought was worth patentable. My view about, goes into the patent corpus has gotten a little bit more nuanced since then. But, just this idea of all this scientific knowledge, that even back then, this 2012, 2011, you could fit into a thumb drive, at least if you ditch the images then, but it wasn't functionally accessible. Even just, figuring out how to pull out simple facts about basic attributes of technologies was beyond modern search or analysis capabilities. So I started getting really fascinated about how the heck could you, pull information out of this great mass. And that led me into the field of natural language processing, which, right around then was really starting to evolve towards more machine learning or statistical based methods. So that in turn led me into the world of machine learning. In a nutshell, one of the grand challenge kind of areas that machine learning has been uniquely good at solving, and those boom times continue more than ever today, is dealing with language and classifying it, tagging it, pulling information out of it, et cetera. So kind of went from this big pile of documents that I was fascinated about how could we use computers to pull information out of, to natural language processing right around when it was shifting towards machine learning. And that led me to machine learning and ultimately back to grad school and Snorkel.
And as a brief detour, you used the terms both ML and AI during your introduction. And that's one of the things that's always interesting to get people's perspective on what is the, semantic difference between those two terms, or are they just synonyms of each other? I'm curious about your take on that.
I won't do as good and complete of a job as, an intro to AI textbook or course, but, in a nutshell, machine learning is a subset. AI is, I won't even try to give a proper definition, but broadly speaking, the field of techniques for automating things that we traditionally associate with intelligence. And machine learning is the subset of AI methods that basically, learn to do this automation from data rather than from kind of manual programming of that automation. And I think maybe one of the key things that we'll touch on, I'm guessing later, is that, it's key to point out that it's never just learning from data. I mean, it's effectively never. When you're talking about in practice, there's always some kind of manual specification of the domain expertise about the thing you're trying to automate. And, which parts of the machine learning system are truly learned from data and which are kind of learned automatically, and which parts involve human specification, is one way of phrasing kind of the practical problem of building ML in my view. So we'll come back to that. But in a nutshell, ML is the subset of AI where you're actually learning to do this automation from data, at least in part.
Effectively, AI would incorporate or encapsulate the purely expert systems approach where you just have a decision tree where some subject matter expert says, in this situation, choose this path or this path. And, machine learning is the portion of that overall umbrella that says, we will take some of that input, but we're actually going to use observed data from this particular subject domain to be able to influence what that weighting of the decision tree might be.
Exactly. And I think that example of, kind of learning the weights or tuning is a great example. I mean, like if you take the simplest form of machine learning, I think kind of where you're, taking some hand engineered features and kind of learning some kind of weighting over them. And let's start with a simple linear one. Then it's exactly that. I mean, imagine another example is, spam filters. Say if I see the word, loan, then I think that maybe makes it spam. If I see the key phrase, please let your father and I know when we can see you, then I think it's not spam. And if I see the phrase, used car, I don't know, I think it's spam. And how do we weight these, right? And so, basic machine learning is you still have actually, this is the classical approach, kind of pre-feature, representation or deep learning, where we still specify those, but we learn from data, from statistics, kind of how to weight them in terms of their correlation with the target prediction variable, spam or not, say. And then, of course, one of the big shifts in terms of the types of AI technologies that we practically use today, not a fundamentally new idea, but in terms of practical usability, is this idea that we can also learn which features to pick out as well, right? So we can go just from kind of labeled, what we call training data, to this model without basically learning the features and the weighting as well.
That fits in nicely with the work that you're doing at Snorkel. So I'm wondering if you can just give a bit more context and detail about what you're building at Snorkel AI and some of the story behind how you ended up building a business around what started as an open source project that was the output of a research endeavor.
Let me dive in. And if I forget and you're curious, we can go back into why I say AI, not just machine learning. The TLDR is that we support today on our platform involves often a mix of, learned components and other operators. So, that's actually why, I'm being more precise if I say AI in terms of the full output or that users build on our platform. But mainly I'll talk about the ML part today. And so in a nutshell, Snorkel started as a project very broadly scoped to study the shift we were seeing, or rather that we were kind of betting was going to come into play from what we call model-centric to data-centric development. So if we looked at how people build machine learning models, it used to be that you start with some labeled data that the model learns from. Here's a bunch of emails labeled spam or not spam. We call that training data. And that came from somewhere else that you didn't care about as a machine learning developer. It's exogenous to your process. You download it from Kaggle or from a benchmark data set, or you got it in a spreadsheet from a subject matter expert or line of business partner. And then you started building your model and doing feature development and bespoke architecture design and all that kind of stuff. And we started seeing the shift where the models were getting more automated, more push button, more supported. Projects like TensorFlow and then soon after PyTorch were just taking off, and deep learning was coming back into vogue with new ways that made it really practically usable and increasingly effective. And all these techniques were showing this trend toward the models becoming more push button. So a lot of the research project was very broadly scoped as, okay, if the models are becoming more push button, what's the new bottleneck? Where does the development activity go in machine learning? And what we started to see was that it kind of shifted to the data, because these models, you don't get anything for free in life, right? So they were, much more push button automated, but they were much more data hungry. And specifically, they needed lots of this labeled data. And so this data labeling and relabeling and curation and broader set of operations around the data was becoming what people got stuck on, but also what people were starting to kind of get creative around, hacking together. So we really started at a very high level of saying, look, let's imagine that the model is effectively fixed. We'll just, put table stakes down that it's gonna get solved increasingly and bet on that trend. And as academics, let's focus on how people develop this data. And can we, in particular, look at ways beyond just labeling it by hand, spam, not spam, spam, not spam, one data point at a time. So that was really how the project started. And then we decided to start on looking at labeling as one of the key operations and understand, can we make it more programmatic? And this was also influenced by working with all kinds of subject matter experts in all kinds of settings where it's not just cheap to label, right? A lot of ML is kind of used to things like spam, not spam, where you have some data that's labeled by people clicking those buttons, or data like, cat versus dog or stop sign versus pedestrian, where you can kind of ship it out to crowd workers and get it labeled effectively. Or think of other examples you see all the time. Customer churn prediction, where you know if a customer churned or not, right? You've got the label already. We were, back to my little personal intro, always fascinated by and anchored on these problems where you had very unstructured and unlabeled data. You were trying to pull some stuff out of some medical records or out of patents or out of the scientific literature. So we did a lot of work with, doctors and scientists and folks in, areas of very private, highly expert data. Today, government, finance, insurance, medical and healthcare, telecommunications and stuff involving user data. So all these settings, it's not easy. In fact, the largest organizations in the world, many of whom we've deployed tech with and published with, are kind of blocked on this task of labeling and relabeling training data. So we looked at this and said, okay, can we make it more programmatic, more like software development? And that's, one of the kind of key anchor point or starting point ideas around Snorkel is this idea of writing what we call labeling functions to programmatically label data. And a lot of the academic project was about that and about how you deal with the noisiness inherent in this programmatic labeling approach, which formally we refer to as weak supervision. Can go into that more later about how you kind of clean that up and make it usable for machine learning models. But really, then from there, the project and now the company zoomed back out, again, this broader idea of data-centric development. What are these operators and operations and sources of signal you can use above and beyond just kind of click, click, click one data point at a time to make ML data labeling and development, faster, more auditable, more adaptable, again, more like software development. That's ultimately what it was. And we study all kinds of things, labeling, slicing, augmenting, sampling data, all these data operations, and said, how could we make all of this more like a structured software development process where you could sit down and build a training set in, an hour or a day. And then when something changes in the world and you need to relabel or reshape it, you just edit it like you would with any other kind of code and ship it out again. Versus what it still often looks like today, 6 or 7 years later, which is, months of people clicking one data point at a time for every single turn of the crank, which increasingly folks are seeing is, even for the largest organizations in the world, just not feasible for productionizing ML. That's the project in a nutshell. And the company spun out of that really as we started to go from some of the core ideas and theoretical and algorithmic techniques for dealing with these more programmatic approaches to this realization, really, that was kind of, hit in the face of it from the users of the various open source repos and projects we put out, that, hey, this is just a new development process. And the ideas are great. The theory and the algorithms are key to it, but also it's a whole new development process, needs new workflow tooling, new platforms, new IDEs, new tools, et cetera. And that was what we spun out the company Snorkel AI to build, and what we've been building and serving to customers over the last 3+ years.
And there are a lot of interesting areas to dig into there. One of the things that I was thinking about as you were commenting on how you are trying to turn this labeling exercise into something that's more akin to regular software development is the question of how do you handle testing and validation of those labeling functions to make sure that it's doing what you want it to do, just like with regular software, where it works when I run it manually, but then when I actually put it out in front of real people and real data, I find weird edge cases and bugs that I didn't know about. And so just identifying when you're starting to hit those edge cases and failure conditions, and then what the error handling logic looks like when you do hit a case where, okay, this labeling function is getting data that it was never expecting to, it's, seg faulting or issuing a traceback or whatever it is. But, maybe that's 1% or 5% of the actual data assets. And for the majority of them, it runs fine. And so just being able to handle that, testing, validation, error handling aspect of the iterative development process that goes into building those labeling functions.
That's a great place to go to for framing, both the ideas and also just a lot of what we build today, right? And the reality of this workflow. Because, and again, that's why I often use this idea of software development, right? There's a lot of, and I'll circle back to your question in a second, but just to kind of, frame, there's a lot of noise out there in the market, the commercial market, and frankly, various, parts of the academic literature too, of we're kind of claiming to kind of make this data development, problem go away. Some kind of just solve it with some kind of push button label it, push button approach, push button auto magic approach, right? There's a lot of logic that sounds very circular and indeed is completely circular. We're going to, automate the labeling with a model to label data for a model, right? It is actually as circular, down to the core idea as it sounds. And that has never been our goal. And I think it's important, even with prospective customers, users, collaborators, to reframe that way and say, look, we're trying to make this a software development process. And it's fundamentally about making it as efficient as possible for the human in the loop, but not kicking the human entirely out of the loop, rather just making it structured and fast. So what does that actual process look like? Well, let's go back to the example of software development. Be too precise here, but at a high level, when you're going and taking some code to compile it, right, you have a whole bunch of techniques, including newer statistical ones using machine learning like we do, that are, automating some of that process. But you also have, a whole bunch of manual validation at various levels. You have manually written tests, and then you have just actual, usage out in the field and rigorous ways of testing that. And then you have, tools for iterating and debugging, right? And so there's kind of a parallel to that there is a direct parallel to that in, how we build our platform Snorkel Flow. So there's a part, and this is a lot of what the academic project and my thesis works and many others now study, this weak supervision idea of using theoretically grounded techniques to figure out kind of how to up and down weight and trust the different labeling functions, actually without needing any ground truth. So the cool thing, and this builds on very old theoretical ideas, once you have a collection of labeling functions, even if some of them are straight up worse than random, adversarial, as long as the majority are decent because someone's trying to, non-adversarially develop something, in a positive way, which is one of our base kind of symmetry breaking assumptions in the theory and the practice. As long as you have a couple of these labeling functions, you can look at how they agree and disagree with each other, and you can back out with formal guarantees kind of which ones to trust, which ones might be correlated, which ones to trust where in different parts of the data where they're better or worse. And so there's a lot of the theory and algorithms, and we can talk more about that. Let's say that's the automated part. That's bucket one. Then there's bucket two of just good old fashioned testing, which we strongly recommend, right? We include a lot of tooling for just manual annotation of testing and validation splits. And we think that's the most kind of trusted and basic way to validate, a final score before you want to say get permission to put it in production. Again, the key point there is, you can usually label a, infinitesimal fraction of the data that you'd otherwise have to label for training the model just to kind of spot check it over time, right? And then, potentially most important of all, there's the debugging tools, right? No matter how much automation you have, garbage in is still garbage out. No theoretical tricks will cover that up. And, writing better inputs will produce better outputs, and not just better, but adapted when you have to change things over time. And so these tools that guide you back and say, okay, where are there error modes in my data? Where are there modes where there's been shift, either with the data distributions coming in or with my output objectives, because the team needs, a different set of labels now or something like that, which happens all the time, right? So again, just in summary, there's a whole bunch of kind of, fancy automation that we spent years working on and has, cool theoretical ideas and cool, impact in practice, but it's critically complemented by, lots of kind of good old fashioned kind of standard validation, blind held out test sets, regular checks and refreshes over time, regular efforts to audit and govern and debias, et cetera, that all ML practitioners should be doing. And then there's the debugging loop, which is a big thing that we build around.
As far as the point that you were making where you potentially have this cold start problem of I have this data that I need to label, but in some cases the labeling function is almost as sophisticated as the model that I'm trying to develop with the labeled data. And I'm curious how you have seen people approach that problem of working with complex data sets. So maybe you've got audio data, video data, image data that you're working with, or even in the case of NLP, where you have to try and bootstrap for a particular application of, sentiment analysis within a particular language community or something like that. Using the image data use case as an example, I want to programmatically generate appropriate bounding boxes for identifying, people on a bicycle in a given context. But in order to do that, I need a machine learning model to do the object detection to build the bounding box. And so I'm just wondering how you approach some of those kind of complex scenarios of being able to generate label data for complex or sophisticated data types and use cases.
Let's go with that example. We can also talk about, well, anyway, so I think there's a kind of a suite of ways that we approach this and have, both researched over the years and published about, as well as spent and are spending lots of effort building for all kinds of use cases and data types in the platform today. I'd start with the first one is just, the basic but super important answer of making it easier to write these labeling functions and other operators, making it easier to do this programmatic development. especially for the folks who actually know about the data. We often refer to as the subject matter expert, right? So, this is like, for example, making it easy for, we've done a bunch of publications with the Stanford Hospital and the radiology department and others there, make it easy for a clinician to, click on a mass in an image and say, well, without writing a line of code, say, okay, well, if I see a bright mass that's bigger than this number of centimeters in this part of the image, that's a signal that it should be labeled as malignant or something, right? So, and this is similar to, other efforts to make software development more, no code or low code. And this is both for data scientists who just want to move quickly. Here's an artifact, or here's a keyword or key phrase in a document indicates it should be labeled this way. Let me just kind of point and click real quick, as well as for actually looping in the subject matter experts who actually have the rich domain knowledge but may not write, code into the process. So that's kind of bucket one. There's a second bucket, which is a lot of technology we've developed, and my co-founder published a bunch of papers about some of the early work here about automating the generation of these labeling functions and other operators. So you can start with a seed set of a couple labels, not anywhere near what you need to train a model, but this can be used to auto-generate or auto-suggest labeling functions and other operators that then you can kind of review and approve, right? So you're still, curating with human knowledge, but you're just kind of reviewing auto suggestions or generations. And so, we have that in the platform today. And that's how a lot of users start, especially in these high cardinality problems where you have, maybe hundreds or thousands of classes. You'll upload a little bit of labeled data. Maybe it's, very imperfectly labeled, which is almost always the case. And Snorkel Flow will auto-generate a bunch of these labeling functions. And then you can basically start, warm started, not cold started, and edit from there. And then the final, and this is in many senses the biggest idea behind all the stuff we worked on and all the stuff we build, is just this idea of all of this is about pulling in organizational knowledge or domain knowledge into the process in ways that can include, but also are much more expansive than just kind of labeling data, right? So this idea of a labeling function, it's kind of like a low-level mechanism, or it's like a low-level API. The bigger idea is I've got all this knowledge. It's in, my head as a subject matter expert. It's in codified sources like knowledge bases or rule sets or business logic, specifications or lexicons or dictionaries. It's in existing resources like pre-trained models that detect bounding boxes, or now large language models or foundation models. And how do I get all this information into a model for a new data set and a new task that is specific to what I need to do? And effectively, what we're saying with this whole approach is that you can get it in via the data. You can use all these resources to shape your data set and then use that, right? So the abstraction is often this labeling function, right? So I can use a labeling. We just posted a paper from the research team at Snorkel about using zero-shot learning and large language models to basically turn natural language prompts from users into labeling functions. We have work on how to use labeling functions to auto-generate them from ontologies or knowledge bases. Let's say I'm trying to tag some symptoms in a medical record. I can auto-generate those labeling functions from a bunch of existing medical terminology ontologies, et cetera. But again, the high level idea is, let's not do what a lot of AI people do, which is to say implicitly or explicitly, throw out everything throw out that expert knowledge, throw out those expert systems, throw out everything else, and just start clicking, labeling data one at a time. Every single time you want to turn the crank for machine learning. And instead we're saying, no, let's use all that signal, any of that signal, including the signal that's really messy, labels you have sitting around that are stale, models that aren't good enough are around maybe even just related tasks, knowledge bases, language models trained on web data, all this stuff that's not going to solve your task alone, but you can use it to label and develop data and power your models. That's kind of the bigger idea here. Sorry for waxing poetic about it.
No, that's definitely great. I appreciate all of the context and the examples there. And particularly one direction that I want to go to in a minute, but keeping on with this theme for a little bit longer, is you were pointing out, existing models that maybe aren't perfect, which brings in the possibility of saying that I have this model, I've started to detect that it's undergoing concept drift because the world is changing around it, but it still has some of the context and a decent amount of the detail that I'm trying to capture. So now I'm going to use that as part of my relabeling regimen to be able to say, okay, here's 80% of what I'm trying to do, but now I'm going to write a function that will kind of complement that to adjust for some of the skew that I'm observing in the real world operation, so that I can then get a higher accuracy of the labeling function that I want to feed into the retraining of its replacement model. So basically, you're kind of in sort of the workspace analogy of, I'm hiring somebody in to train as my replacement so that I can go do other things, or so that I can go retire.
This idea of, this is a way of kind of, adapting and repurposing, information. Again, this is a very classical idea in AI, not just machine learning, AI of, how do I repurpose old knowledge for new tasks, right? And in some ways, we're trying to make it look more like software development, where you can take kind of old existing models, labels, sources of information, business logic, sources of signal, use it to get started, and then iterate on it with code, right? To make it more concrete. That's how a lot of projects in Snorkel Flow start, especially these bigger, more complex ones. You dump in a bunch of these kind of sources of signal. I'll give an example. One of our customers, a large global insurer, for one of the problems they tackled, they started with, for one project, 85,000 labels from junior underwriters that they estimated were about 60 to 70% accurate. This is for like a multi-100-way classification problem. And then they iterated from there. So they then looked at some of the analysis tools that we have and said, okay, here are the classes that are getting conflated. Here are the error modes. And then did iterations to make targeted corrections to those with the labeling functions and other operators. So, definitely it's this old idea of repurposing and adapting, whether it's to bootstrap a new task from 0 to 1, using some of the old things you have laying around, or to just modify an existing task as things shift in the world. And in some ways, we're just letting you use more programmatic or kind of software development techniques, rather than a lot of research is focused on the completely automated way. And that's cool. And we use a lot of those techniques too. But in our experience, you have to be able to have the human in the loop to do this intervention and modification and development. And that's kind of what Snorkel is about.
For organizations who are either starting their journey of implementing machine learning and they are exploring the so-called traditional approach of managing their labeled data, or they're already in that loop of, we manually labeled our data, or, we hire one of these data labeling firms, or we use something like Mechanical Turk. What are some of the kind of decision points or customer education that you work with them on to understand what is sort of the cost benefit of continuing with that manual labeling approach, where you have a fairly high confidence that you're going to get a higher accuracy from those manual approaches, versus going this programmatic path where maybe it complements the work that they're doing, but it allows them to scale more economically and effectively?
Let me just start by pulling out that point that you made about kind of complementing. This kind of goes with what I was talking about a bit, this idea of, it's not just about like labeling functions and programmatic labeling. It's really about this bigger idea of pulling in all the information and being able to edit and iterate and develop it like software, like you would with any other kind of piece of code. We have lots of projects, some of which we published about, others with customers, where there are both manual annotation and programmatic approaches being used. And in fact, that is actually something that we build core workflows around. On the one hand, how can you speed this up and also make it more auditable and adaptable, et cetera, through programmatic approaches? But then how can you use your subject matter expert collaborators, many of whom are very busy for we work with a lot of data science teams who are kind of having to beg for time from these partners who know how to label the data. How can you make better use of their time by being more targeted? We actually have a manual annotation kind of focus mode to our platform. And we have a lot of workflows that support things like doing some programmatic iterations, being guided to some of the error modes where you're getting stuck, and then sending those slices of the data out for manual annotation or programmatic annotation in simple ways by the subject matter experts and back. And so the reality is that you almost always have both of these folks in the loop, and you have a mix of some, programmatic to speed things up, but then also manual review, at very least for final testing and validation, which we talked about at the beginning and we thoroughly recommend. So that's an important note to make, because we work with data science teams as our primary kind of users and customers, but almost always, 99% of the time, there's a kind of subject matter expert or annotation team who we're also trying to support and work with very closely. We're trying to save both of those groups time and also make the process more kind of manageable, auditable, et cetera. Back to the actual decision tree, I'd say one decision point, is kind of basic. It's just, are you struggling around, the construction development of the training sets? Now, most people start to struggle over time because of things like drift and everything. But there are problems where, you'll look and say, okay, look, I'm customer churn prediction. I already have those labels, organically collected or really cheap for me to get them in this zone where I have 15 columns and I want to predict column 15 from columns 1 through 14, right? Structured labeled data. We can help there. We can help denoise the labels and help make them more adaptable, et cetera. But maybe that's not your biggest pain point. A lot of the folks we're talking to, they have very unstructured data and they don't have the labels, and it's a major pain point, right? So we tend to gravitate there also just because we like to pick the biggest delta as a small company. And then once you're there, then I think a lot of what determines it is what is the cost associated with throwing people at the problem in kind of the old way. And the cost can be both kind of time and monetary, but also things around governance. How do I actually check the labeling of the data? How do I prove that it's bias free? How do I correct it and adapt it over time? And so if you have a really simple problem, stop sign versus pedestrian, even that one is tricky. Actually, I've gotten pushback when I've used that as like a foil in talk tracks before, because there are all kinds of edge cases, and it's not, again, not a simple problem. But just to use as a toy example, you've got settings maybe where most people know how to label stop signs, and they don't change that much because they're kind of restricted from frequent change by regulation. Versus if you're dealing with legal documents in a bank or clinical information or government, like all this kind of stuff where it's often very private and it's constantly changing and it requires special experts to label it. And then you're looking at the effective cost of training data labeling and development that is prohibitive even for the world's largest organizations, as we published about with Google and others. So that's a rough guide. Are you in this kind of land of unstructured, unlabeled data? We think of this as kind of the iceberg under the surface of ML applications today, where you're really going to run into this right away. And then, are you especially going to run into it in a painful way because you're not dealing with trivial problems that are kind of, cheap and quick to label? That's a rough guide that at least we use to try to find like the highest value problems that we know how to solve.
Yeah, and the evocative terminology that I think you had used when you first came out with the Snorkel project was calling it dark data, or sort of data that is yet to be sort of unearthed and turned into something valuable.
Yeah, and it's still the case. I mean, it's striking the level of talent and technology that's kind of coming into the enterprise via data science teams. I mean, I'm sounding like I'm just trying to suck up a little bit, and maybe I am, but I really mean it. Like the talent is there, the spend is there, the tooling is there. I mean, especially both through vendor solutions and internal tools, but also just out in the open source. But the number of teams that are kind of blocked on the data because they can't even start training the latest fancy machine learning model that's out there in the open source until a line of business team has spent several months labeling data. Like, it's crazy. So that idea that there's this data that it's dark for the broader organization, because it hasn't been refined and classified and tagged and extracted by ML methods. But it's also really dark for the data science teams who just don't have it structured and refined in a way where they can use it.
Predabase is a low-code ML platform without low-code limits. Built on top of their open-source foundations of Ludwig and Horovod, their platform allows you to train state-of-the-art ML and deep learning models on your datasets at scale. The Predabase platform works on text, images, tabular, audio, and multimodal data using their novel compositional model architecture. They allow users to operationalize models on top of the modern data stack through REST and PQL, an extension of SQL that puts predictive power in the hands of data practitioners. Go to themachinelearningpodcast.com/Predabase today to learn more. That's PREDIBASE. And so bringing it into the Snorkel Flow platform that you're building, I'm wondering if you can talk to some of the overall design and functional elements that you're providing there and the way that you approached the implementation and integration points for people who are using it and want to hook it into their overall ecosystem of data engineering or ML ops or custom internal tooling.
Integrations alone is a huge topic, but let me start with kind of the basic workflow that we support. So a lot of what we built is based around this kind of core, what we think of as data-centric development workflow, where you start with labeling and more broadly developing your data programmatically. This is, labeling. We talked about this idea of labeling functions, of, labeling via code. Other operators like transforming or augmenting data, slicing data, sampling, relabeling, all these operators that we've published about and talked about broadly make up these kind of very critical AI operations. But we'll start talk about labeling today, right? So you have this first, area where you're developing these, and we call this Studio. And a lot of this is based on offering a stack of interfaces all the way from hosted notebooks and the Python SDK by which you can just write these labeling functions as code, all the way up to auto-generated point and click, even kind of natural language interfaces that make it easier and faster, more accessible to write them. So that's the kind of stack and kind of Studio or IDE there. Then we have this kind of weak supervision component that is figuring out how to clean and combine and model those inputs. And then we include a full AutoML suite that gives, basically feedback, right? So we can come back to some of our users actually use this, and then we support MLflow export format and others to basically take the models out, or even the more broadly applications, which can have multiple components. Some just pull out the training data, but all of our users use this because it's the way that you actually get feedback. It's the way that you avoid flying blind, right? If you're just labeling data, you could be spending, especially if you're labeling manually, you could be spending months labeling a part of the data space that is really not helping model performance, right? And missing critical error modes. So that key part of the loop of labeling data programmatically and or manually or via other sources like we talked about, cleaning it up, but then training a model to give fast feedback about where do I go next, both via active learning approaches, which kind of guide to where the model's confused, but also a range of other analyses about basically where do I go next. That's the core loop. And so I'm simplifying quite a bit. And I'll note that a lot of our effort, a lot of our engine product effort working with customers and users goes into all the rest of the stuff that you need to tackle with these complex data types and problem types. Let's say you want to build a news classifier. A top 3 U.S. bank built a news classifier on top of Snorkel Flow. That was actually what we call an AI application. We have a blog post about this because it was not just a model. It was a model to tag entities in news feeds, and then a model to link them to canonical identifiers like stock tickers, and then a model to classify the semantic role. And a lot of these problems over natural language data and image data and others really need to be broken apart. And it's a lot more complex than just building a single model. So there's a lot more there. But this basic loop of just labeling and developing your data, cleaning it up automatically, and then getting feedback from a range of analyses, including from kind of ones that are driven by models, that's the basic loop we support. Now, all of this is accessible in a GUI. And the newest one that we just rolled out, like literally this whole loop happens, automatically. You poke around your data, you can develop these labeling functions or auto-generate them in other operators. And then a model trains in the background to give you feedback about where to go next in real time. So that basic loop is there. But then one of the key design principles that we've worked around from the beginning is mapping everything in our workflow to a Python SDK or to Python SDK endpoints, one-to-one, so that you can always kind of mix and match. Because especially with the sophisticated teams that we have the privilege of working with, but just in general, there's open source tools, there's internal tools, there's vendor solutions. We want to plug in very easily, right? So you can do all of this, and then in Snorkel Flow, and just ship out a package at the end that has the model or the application. You can pull stuff in, you can pull stuff out, right? So everything is accessible and drivable via Python SDK, which is kind of how we have other push button integrations, but that's how we make sure there's always kind of a way to kind of mix and match and integrate for the developer.
To that point of integration too, I'm also curious how you think about working with the overall experimentation cycle of, I have this model that I'm trying to develop, trying to do it for the first time. So I'm going to see, which layering of networks are going to give me the best results. And I'm going to tweak the labeling function to label things in a certain way to be able to generate a certain set of features for how the model wants to think about the problem space. Okay, that didn't work, so now I'm going to go back and tweak the labeling function to regenerate the training set, to rerun the model development, and just working with that kind of flow of the machine learning process and how that's maybe disjoint from the kind of software development flow that some people might be familiar with.
Just to start with the first point, a lot of our design principles for the platform and the workflow really just derive from this view of data-centric AI development. And as a side note, if I didn't, make this clear enough at the beginning, I think now this phrase is getting more used as a buzzword, and people will shorten it to data-centric AI. And I don't want to, play the stereotype of, pedantic academic, but not even in an academic sense. The real intention, at least from us, is to say data-centric AI development, right? Because AI, in so much as people are mostly talking about ML these days, has always been data-centric. It's literally in the definition of machine learning. We mean development in terms of what's the kind of main object that you're developing for the majority of your time. Is it the model and attributes of the model, or is it the data? So we build our workflow around this idea that, the data development is the main thing that you need to be able to iterate on, and the model development can be largely automated or kind of, done more minimally. And you see this with the proliferation of both. I mean, there's a whole bunch of trends that lead into the kind of model development being more automated. Some of them are just, first big wave is just deep learning models or representation learning models that take away a lot of the need for manual feature engineering in many cases. Then you've got also the convergence of architectures, right? Increasingly, a whole range of tasks are accomplished by an increasingly consolidated set of model architectures. And then you've got progress in AutoML, where, basically a lot of the kind of, experimentation to find the right model or the right configuration and tuning of the model can be automated itself. So a lot of our building is done, based on this bet that mostly you're going to be wanting to iterate on the data and just kind of push a button to train a standard architecture or do AutoML. Now, of course, it's never that, black and white, and we're not dogmatic about this, right? So we offer some capabilities for doing model development, and then, data-centric development works because there's been great progress with model-centric development, right? So there's where we, make it really easy to integrate with other platforms or internal tools for doing that model-centric development. But again, our bet is that you're spending most of your time and you're getting kind of the biggest bang for your buck iterating on the data versus kind of, tweaking different configurations of a model. But again, we're not dogmatic, depends on the situation. And that's, again, where integrations, as well as tooling that we have and inherit from all the great open source progress, or kind of, hook onto, is a practical way forward.
And then the other element of the model development process is the question of explainability and what impact are these different features that I'm pulling out of this labeled data set having on the overall performance of the model. And so I'm wondering how you have seen teams use tools such as SHAP or some of the other explainability projects for being able to say, okay, based on this model training, based on this data set, this is the explainability of, these are the networks that were being activated based on this set of data, feeding that back in to say, okay, I'm going to, enhance the logic for how I label this particular attribute of my data set or add more metadata to this object at the point of labeling to be able to get some better outcome from the model, and just that overall cycle and how explainability factors into this data-centric approach to AI development.
Explainability is a huge topic. And again, an area is exciting. I mean, if you can't even have full agreement on the definition of the desiderata, then it's, definitely an exciting, intellectual space. On the kind of production and practical or commercial side, one should tread carefully around. So explainability is a huge area, and I'm not the expert to speak to that progress. But what I'll say at a high level is that I think one way to bucket it would be to say, okay, there's one definition of explainability around models, which is, can I explain in an interpretable way kind of why a model made a certain decision? And then there's the part that we focus more on, which is, can I actually, trace back model predictions to parts of the data and actually have, lineage and pathways for editing and also for auditing. So I think that former one is, and that's where, there are approaches like SHAP and others for this, as well as, tons of research. That's something that, strictly speaking, a lot of the stuff we build is orthogonal to, right? We can work with any models and then any techniques for explaining the decisions of those models, right? But a lot of where we focus and offer, and where this whole kind of programmatic approach offers a very unique and often very significant advantage in a 0 to 1 kind of way, is this ability to actually, be able to audit and, trace lineage around your training data, right? If you label a bunch of data by hand, there's some interesting work on tracing kind of model errors back to specific labels, but, really auditing a manually labeled data set is a very difficult thing to do. Theoretically, like as harder than the problem you're trying to solve often by labeling the data. And then going and correcting it or debiasing it or anything like that is equally difficult because you have to relabel massive parts or potentially the entire training set. When your training set is labeled by code, you can, go back and just make edits to that code, relabel and proceed. And so this ability to both have kind of auditability and explainability of how your data is labeled, as well as to actually take action in a really concrete way, is kind of one of the big advantages of our approach. So that's a little bit of a shift from traditional model explainability, but we find it to be very important and practical to have this kind of data explainability and, also ways to take action to correct or debias.
Another aspect of what you're building at Snorkel AI is the fact that you did build it on top of this open source project that you built as part of your research. And I'm curious how you have been approaching the question of governance of that open source project and how you think about the boundaries between which features live in that code versus which features live in the platform for the sort of commercial feature set, and just how you're managing the community element of sustaining this open source project while still building a viable business around it.
We're actually a little bit different than the kind of open core models that you're kind of speaking to there. And the platform Snorkel Flow that we build and sell commercially is 100% at this point new code compared to at least, the open source repos we've had out there. There's one that I guess got a lot of attention. There are, dozens or I think potentially hundreds that really were in our research artifacts or research repos, right? So those we're always going to maintain and keep out there at minimum for commitments to scientific reproducibility and for their kind of value in helping to illustrate the concepts that we've published about out in the open for years and still publish about. But they're not production open source projects, and they're distinct from the platform that we build today, which incorporates ideas from all of them over the last 7 years, but plus a lot of new stuff, but is distinct.
And so, in terms of the ways that you have seen your customers using the Snorkel Flow project and the Snorkel AI platform, what are some of the most interesting or innovative or unexpected applications that you've seen?
First of all, is just we've seen, even with kind of basic use case, some really cool impact in deployment, in terms of saving hundreds of thousands of kind of person hours of work that wouldn't have gotten done otherwise, clinical trial records and financial documents and insurance records and all kinds of stuff like that. Other creative applications I think have come out of this functionality we've leaned into around enabling kind of multiple models or operators to be pieced together. I gave one example before about large US bank kind of putting together a news analysis application that was tagging, linking, extracting. This isn't a novel thing. A lot of the real especially in NLP applications are pipelines of operators, but opening that up has led to lots of creativity, breaking problems down into hierarchical decompositions and solving them that way. That's been really cool to see. A lot of what maybe our recent learnings have been over the last year or two is just the criticality of looping these other stakeholders in, right? Of having, not just data scientists, but having, subject matter experts and annotators in the loop, giving signal in various different ways, tags, comments, labels, labeling function ideas, operators, etc. And learning to kind of better support those loops has been very interesting in terms of learnings around how to build the right workflow.
And in terms of your experience of going from research and academia and building this open source project as a sort of artifact of the work that you were doing, and then building a business around those core ideas that you were researching and experimenting with, I'm wondering what are some of the most interesting or unexpected or challenging lessons that you've learned in that process?
Tons, obviously. I don't think I get away with even trying to claim that I knew even a fraction of requisite things walking in the door. I think there were a lot of, and I'm not saying this is a shameless pitch for grad school, but I think there were a lot of lessons that, added the appropriate and very critical grains of salt or modifications did transfer around how you communicate to users and collaborators, how you go about actually, getting them successful with new techniques. A lot of the learnings have been saying, how can we adapt ways that we went about things to this different context? And we find out that there's obviously a ton we learn, but there's some similarities, right? In how we engage with users on the academic side of, not just kind of throwing an algorithm over the wall, but trying to understand and, help them scope problems, help them set up the right metrics, scope how to evaluate. We have a similar motion in our process of engaging new users company side now too. Biggest learnings. Some things are obviously, slower out in the commercial world, but some things can be faster too, which is pretty cool. So, there's some places where I've been blown away by how quickly stuff can actually reach production, have impact. I guess nothing new there, right? When you're in, on the academic side, you can produce things at times more quickly, but they're meant to be upstream. They're meant to kind of, spread ideas, right? And some of the applications, take a little longer to kind of diffuse down. Whereas when you're out in the field, sometimes things are slower and there's more process and tougher requirements and everything, but then you can just kind of, ship stuff to prod and it's, out there. We were fortunate working with, all these, Fortune 100 companies and government agencies and, other folks who have, massive scope of impact. So you get to make a change there and you see it, have pretty huge impact. It's extremely exciting. It's all differences. I guess that's the generic thing to say, but it's been super cool to see the different ways in which we both had new learnings and new access to, getting hands-on with customers and users in ways that, were harder in academia, as well as new opportunities for actually, shipping ML in impactful ways.
And we touched on this a little bit earlier, but what are the cases where Snorkel is the wrong choice and somebody may be better suited with just manual labeling approaches?
First answer I'll give is we include, full capabilities for manual labeling. So I would say with that bifurcation, never, with my sales hat on. But the broader question of when is it not a best fit? I mean, one of the ways that we're trying to make that easier for everyone to answer is we do a lot of work to, templatize various use cases that we, both offer more push button kind of pre-templatized support for, but that also can help guide to kind of where we're a good fit. Right? We're a very broad development platform. We've published for years, in true academic fashion, kind of breadth first of everything from, core ads tech to self-driving to genomics to all kinds of stuff. On the company side, we try to use this templatization again, both to improve the experience for, core use cases, but also to help guide to where we're best suited in a really, kind of granular way. That sounds like a non-answer, but it's really just to say, look, we have this library of templates that we continue to grow and add to, but is meant to kind of help address that question of, hey, where is this platform really good fit today? And, where is it either not ready or not the best approach for via that kind of, use case granularity.
Are there any other aspects of the Snorkel Flow platform and the business of Snorkel AI and just the overall space of programmatic data labeling and data-centric machine learning development that we didn't discuss yet that you'd like to cover before we close out the show?
Too much exciting stuff that, both the team at Snorkel has worked on or is working on actively, and others in the space, are working on. It's really exciting to see this idea really at its core of just saying, hey, we should pay more attention to the data and the development processes, both existing and emergent around the data as ML people and AI people. That shift is extremely exciting. There's lots of cool ideas out there, and I touched on some of the ones that we've touched on about, hey, it's not just labeling, it's augmenting and slicing and shaping and sampling and all these things that, we've published over the years, either in or making their way into Snorkel Flow, our platform. But there's also just a ton of and a growing amount of exciting work out there. And yeah, too much to enumerate. So maybe I'll leave it at that.
Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd just like to get your perspective on what you see as being the biggest barrier to adoption for machine learning today.
I have to say, training data. But, I think the broader piece is also, connection between, all the subject matter experts and expertise, that a lot of folks have in their colleagues, their organizations, their existing models and resources, and, the new task you want to accomplish. And, having the only conduit for that be, arduous manual labeling of data is one of the things that I think has slowed down a lot of progress in ML, and opening that bottleneck up and creating new conduits, that even higher level kind of phrasing. But, I have to end by saying, it's the data. The data is the blocker, but it's also, if you handle it right, the enabler and the interface. So maybe I'll round out on that note.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing at Snorkel. It's definitely a very interesting product and platform, and it's great to see that you have been able to provide a way for people to kind of get over that initial hump of needing access to labeled training data to be able to start exploring AI and making it a reality for their organization. So I appreciate all the time and energy that you and your team are putting into that, and I hope you enjoy the rest of your day.
Tobias, thank you again so much for the invite today. And this is an awesome conversation. I really appreciate it. And looking forward to our next one.
Absolutely. Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.